And good morning. I'd like to thank you all for joining in today's presentation on Windows Server 2012 virtualization. The session today will be presented by Bruce Redfern. And Bruce Redfern, today Bruce is going to facilitate the session, and I'm going to pass the mic over to Bruce.
Okay, thank you, Laura. So good morning and welcome to our webinar series. This one is on Windows Server 2012 virtualization. So we'll be looking at the new features in Windows 2012. In support of virtualization, if you're familiar with virtualization in the Windows platform, you know we're talking about Hyper-V. And just a little background on myself. I'm an MCT. I've been working in the IT industry for about 30 years. The past 15 or so, I've been a Microsoft certified trainer presenting Microsoft technologies, mostly Windows, SQL, SharePoint, and System Center. So those technologies are my main focus in the Microsoft platform. And our agenda today is to have a look at the new features in Hyper-V on Windows Server 2012. We'll look at from an overview level, and then at some specific things like the new networking features. They've made some nice improvements here. If you've been looking at Hyper-V and have perhaps found the previous versions lacking in capacity or in some certain features, you'll probably find something here to help you. We'll look at the implementation of networking in Windows 2012 Hyper-V and the specific changes they've made. They've moved from virtual networks to virtual switches. So we'll look at the Hyper-V extensible switch, the scaling capabilities of Hyper-V, and the NUMA implementation, or non-uniform memory access. We'll look at, and not a lot, but from time to time through the slide deck, I'll point out there are PowerShell commands available for manipulating Hyper-V. And then we'll look at a couple of the big features that came with this product. Hyper-V Replica, which gives us essentially a disaster recovery scenario for virtual machines that are running under Hyper-V, and live migration, which allows us to move running virtual machines from one location to another. We also have the ability to do storage migration, that is, move a running machine from one location to another on the same machine. For example, I need to get it off drive C because it's running out of space, so I want to put the virtual machine on drive D. So I've got storage migration as well. And we also have the ability to have Hyper-V machines now with the virtual hard disks, which are the large space-consuming components of the Hyper-V virtual machines, stored on an SMB share, that is to say, somewhere out on a file share on the network. Now, this gives us an enhanced ability to move machines while they're running as well, because a running machine can be moved from one host to another without having to move its storage, that is, the hard drives and associated files that make up the virtual machine, which can sit out on the server message block share, that is a file share on your network, as long as it's running SMB3, which is the Windows 2012 version of server message block file sharing. So these are the features that we'll look at. I'm going to go through them basically in this order, and I'll stop and do some Q&A at the end. Hopefully we'll have a little bit of time to answer anybody's questions. Okay, so looking at the new features in Hyper-V on Windows Server 2012, they've increased the support for the adapters, the hardware that a single virtual machine can support. We can now support up to 12 virtual network adapters. This was not a common requirement, but in some situations a virtual machine needs to connect to multiple networks independently. And of course you can do this through routing, but if you have the need for separation between those networks, we now can have 12 adapters within a virtual machine. We can assign those virtual adapters static MAC addresses if that matters for software licensing or to avoid having to change other aspects of your infrastructure. We can have VLAN support, which we did have in previous versions of Windows 2012, Windows Hyper-V, and we can now have up to 512 virtual machines per virtual network. So we can build very large and complex virtual machine infrastructures using these new networking features. In the storage side, we have, of course, the ability to use direct attached storage, meaning storage that resides on the local host, but we can also use storage area networks. We have iSCSI initiators built into the operating system, or provided with the operating system, I should say, and the virtual machines can use those to connect to storage that is in a SAN. We also have, and I'll talk about this a little later on, but we have a virtual fiber channel adapter now. So if you have a fiber channel infrastructure, you can use that infrastructure to store your virtual machine hard drives without having to connect the fiber channel to the host machine. Sorry, and I don't mean connect, but I mean surface the fiber channel storage infrastructure in the host machine. It can now be passed through and connected directly to the virtual machine. So that's an improvement as well. So we have virtual IDE devices. We have 2 IDE controllers with up to 2 devices each. We can have 4 SCSI devices, and we can have up to 64 devices per SCSI device. So we have a lot of disks that we can connect. The virtual hard disks themselves, I'll talk a little bit about the, sorry, we're getting a little bit of a problem with voice fade out here, so let me just check and see if I can do anything about that. My microphone is up to the maximum here, so I'm hoping that's just an isolated incident there that one person ran into. And I'll just keep talking here. I'll try talking a little louder. Hopefully that'll help. Anyway, so we have virtual hard disks now that can support up to 64 terabytes per disk. The old limit was 2 terabytes, so that gives us much larger storage capacity. And we, of course, can use pass-through physical disks. So we can have a physical disk located on a host and dedicate it to a virtual machine, i.e. not connected to the host operating system. So that gives us a lot of room for storing virtual machines and for storing the snapshots associated with them. An additional feature in 2012 is the ability to do dynamic memory allocation for virtual machines. We can now specify a maximum, minimum memory configuration, or we can simply set it at a fixed value. And we have an additional facility called smart paging, so that if we assign an initial startup memory for a virtual machine which is not adequate for it to start, but is adequate for it to run, we can, or sorry, I should say, virtual Hyper-V in Server 2012 can use essentially a virtual swap file to allow that machine to get started. Okay, and that will sit in the same directory with the virtual machine's hard drives and snapshots and so on. So it's not new, dynamic memory is not new in 2012, but these additional features are new in 2012. There's a new virtual switch implementation, so if you wish to connect your virtual machine to each other or to the host machine or to the external network, of course you'll need to use a network adapter inside the virtual machine, but that can now be connected to a virtual switch as opposed to a virtual network as it was in 2008 R2 and before. They still have the same virtual network types for those switches, being in external, internal, and private. But the actual implementation is done through a private switch, which gives us actually a little bit more control, because I can do things like mirroring all the data into that switch to another port, for example. New in the network virtual adapters that are connected inside the virtual machine, we can now, of course, connect them to a virtual switch. We can assign them a virtual LAN ID. So even within the same network, we can have virtual machines that can communicate only with other machines on the same VLAN. We can do some bandwidth management. So this is pretty good if you need to make sure that the network bandwidth is, doesn't rise above a certain level for a certain virtual machine, or doesn't fall below a certain level. As available network bandwidth doesn't fall below a certain network level, then you can set that for the virtual machine network adapter. We have the standard synthetic network adapter, which requires the virtualization add-ins, and a legacy network adapter, which essentially is recognized by most operating systems that Hyper-V will run, so you don't need the special driver, and it's good for doing things like booting across the network, doing WDS deployments and things like that. On the virtual hard disk side, I mentioned that the capacity has improved. They have done that by introducing a new disk type called a VHDX. It gives us larger storage capacity up to the 64 terabytes that I was mentioning earlier, as opposed to the previous limit of 2 terabytes. And it also has some logging features that help it protect against data corruption in the instance of power failures, and works better with larger disks. And we have SMB share support for virtual disks. Now I'm going to show you most of these settings when I get to the end of here and just give you a little tour of where you'll see these in Hyper-V. Also with the VHD, we can do conversion, so we can convert. If we had a VHD before, and we are running on 2012, so this VHD feature only works with Hyper-V under 2012. But if I need more space in that VHD, I could convert it into a VHDX, for example. And I still have the capability that I had in previous versions to compact or expand the virtual hard disk. So I set it, when I initially created it, I created it at the default 126 gigabytes, for example, and now I find that that disk needs to get larger than that, and maybe it needs to grow to a 1 terabyte. I can expand it, I can compact it to remove unused space if I'm trying to reclaim disk space in my storage infrastructure. For any of the virtual hard disks, I can inspect the virtual hard disk to see what type it is, to see if it connects to a parent disk, for example, if it's a differencing disk, and of course I can do the compacting. And if I am using a differencing disk, I can merge it with its parent. So I have a lot of control over the virtual hard disks themselves. I was mentioning the virtual fiber channel connection now, so I have a virtual capability. I have a real capability, but it's inside the virtual machine. It's a virtual fiber channel adapter, so I can have a fiber channel storage area network set up. My host can be connected to it, but not using it directly, and that can pass through and be accessed by the virtual machines running on the host. So that gives me another storage option. I've got SMB external, I've got direct attached, I've got SAN attached disks that are visible to the host operating system and then used by the virtual machine, and now I can use a SAN LUN directly inside the virtual machine without making it visible to the host operating system, which gives us some nice sort of portability too, because if I'm using a particular SAN LUN inside a virtual machine, if I move that virtual machine to another host, it can still see that, assuming that the fiber channel infrastructure is in place. As I was saying before, there's a lot of PowerShell commandlets available in Windows 2012 for manipulating Hyper-V virtual machines. This is an example, so creating a new virtual machine. If you just open the standard PowerShell in Windows 2012 now, you'll see a lot of these commands. So if I do and I hope you can see the text here, maybe I'll just change the text a little bit so that it's a little easier to see. Let's pop up to a 28-point script. Here we go. So if I do a get command on star VM star, you'll see that there are a lot of things that I can do to virtual machines. Right? I can add network adapters to them, enable migration, get information about switch machines and switches, create new virtual machines, as mentioned on the slide there, create new virtual machine switches. And so there's a lot of control here under PowerShell available to you if you want to use that as your mechanism. I'm currently involved in a project where we have 5 virtualization hosts, and we're doing quite a lot of virtual machine deployment. And quite frankly, we wouldn't have been able to do that project without PowerShell. And PowerShell has given us all the tools, so whenever we need to deploy a series of virtual machines, we essentially fire off our script, and off it goes and runs commands like this one. In our case, we're quite often importing VMs, so that's another command that's available in PowerShell. Let me quickly pop over to Hyper-V here and have a little tour of some of these things, these features that I was talking about. So I'm sitting on server 1 here. These are some virtual machines that I'm running on server 1. I wanted to show you the standard settings. Okay, so for a virtual machine here, I'm looking at a hard disk which is on the local machine. Right, so it's in the C drive. I know you can't see that especially, but I've hit inspect. You'll see here's the path. So that's a local virtual machine hard drive. I can also use a SMB share to store the virtual machine hard drive components. So here's an example of using a SMB share for the location. So I go to my hard drive here. If I do an inspect, oops, sorry, you'll see that it's / server1 smb.vhds smb.demo.vhdx. So I'm storing the hard drive for this virtual machine on an SMB share. This gives us some nice advantages for portability, because I can move that machine to another host without having to move the actual hard drives. If I'm taking a standard machine and moving it to another host, which is a possibility in Windows 2012, I can move that. If it's on the local hard drive, of course, then the files have to get copied to the other host. So SMB shares give us some good advantages here. The switch infrastructure that I was talking about earlier, if we look at our virtual switch manager here, here's an example, an internal switch. We already have seen these in previous versions of Hyper-V, internal, external, and private. External, internal, and private. You'll see, in addition to the switch configuration here, this is the definition of the switch, and this used to say virtual networks, now it says virtual switches. We have some extensions that we can add, that we can enable for that virtual machine, and we can even write our own and install them so that we can capture traffic that goes through here. So I can do a capture against that data for monitoring purposes. That is the data that's running through that virtual switch, for example. That's on the virtual switch side. On the virtual machine side, if we look at the same component here, where the network adapter here is connected to that virtual switch that I created, you'll notice I have bandwidth management. Well, of course, I have VLAN identification, which I had in 2008, but I have bandwidth management. So now I can specify minimum and maximum bandwidth. I can also do some additional hardware acceleration configurations that I'll talk about briefly later on. And I can enable some additional features that, for example, protect this virtual machine against router advertisements or improperly or unauthorized DHCP servers. So don't let DHCP messages come through to this network machine from unauthorized DHCP servers. So there's a number of things that I can do here that I could not do in 2008. And I can also do NIC teaming. So I can team together two network adapters for the virtual machine, so they look like one, but they're actually two physical virtual network adapters out on the host machine. So a number of interesting changes there. I won't do the virtual fiber channel. I don't have a SAN here. Import of the virtual machines now. There's been some improvement in the import facility. If you've worked with exporting and importing virtual machines in 2008, you'll know that sometimes the import fails and it doesn't give you a lot of options. It just tells you this is the error, and then you have to go digging through the event log to try and figure out what was the problem with this install. What they've done in 2012 is they've allowed you to simply copy a virtual machine. So if you shut down a virtual machine, which you would want to do to make sure that the disks were not actually being modified, you can copy that virtual machine to another location and then import it without ever having done an export. So I can do what they call a raw import, or an import with a simple copy option. When you do the import, you would then, if you're going to put it on the same machine or the same infrastructure, you'd want to give it a new ID, because every virtual machine gets an ID when it's imported. But if it's simply you copied it to a backup media, the server has died, and you want to bring it back with all the same information, you can restore it without changing that unique ID that gets assigned during the creation of the virtual machine. So that's a new feature, the ability to copy from an XML export of a machine. So I did this on this local machine, and so what I can do is I can take a virtual machine that is shut down. For example, this is the SMB demo machine that I was using before, or this file server machine. I can simply copy this whole folder and paste it somewhere else, and then go back to the server and do an import and specify the location where that copied folder resides. So that's what we're talking about when we talk about copy import as opposed to export import. The other thing that they've done is they've improved the import wizard. As I said, a lot of times in 2008, you'd get errors during the import, and you'd have to go and figure out why this import didn't work. It wasn't giving you much information, and it really didn't give you an opportunity to fix things. You pointed it to a location and you told it whether you wanted to copy it or generate a new ID, and then it just went and did it. The import wizard has been redesigned to detect and fix more than 40 different types of incompatibilities that can show up during this process, right? And it will also generate a compatibility report if you're interested in it and go look at it. But it does give you the ability during the import process to go find those pieces. And you can redirect the location that things are going to go to as well. So quite a bit of work done on the import side of Hyper-V. Now, I was mentioning the virtual network adapters, so I'll talk a little bit more about the new networking features and the Hyper-V extensible switch in this section. Advanced features of the network adapters, as I was showing you in the settings of the virtual machine, we can now guard the virtual machine against DHCP and router announcements. So if we don't want it to learn an address or we don't want it to learn a route from an announcement that's happening on its network, the one it's connected to. For example, somebody sets up a machine as a router or sets up a machine as a DHCP server. I can say, no, I don't want this machine to receive those. I was mentioning the NIC teaming, so I can get even better throughput. If I can't yet move up to 10 gigabit per second network, for example, I could team up to 1 gigabit network adapters or two or more 1 gigabit network adapters to build better throughput. I was mentioning the port mirroring capability, so I can, for a particular virtual network adapter, say I'd like to mirror the traffic in or out of the port on the switch that this adapter connects to another port on the switch. You have to set up another machine to receive that traffic, but now that other machine can receive all the traffic that is seen on that switch port, which gives me much better monitoring capabilities. I've got receive side scaling and dynamic virtual machine queue for the network traffic itself, so they've done some work there. I can offload the IPsec security association mechanism to Hyper-V, so that the virtual machine doesn't need to do that. It needs to be done somewhere, of course, but I don't need to have the virtual machine do that. And if I have a physical adapter that supports single root I/O virtualization, I can now bypass the networking stack on the host machine and go directly to the adapter from the virtual machine. So this gives us another good way to improve network throughput on Hyper-V 2012. And I can also use physical VLANs, which means I can actually bridge out from Hyper-V through a physical infrastructure to a VLAN on another Hyper-V host. I'll get a couple of slides later on, but I won't dwell too much because it takes a long time to talk about that. But it's going to be an interesting feature if you want to extend your virtualization solutions across multiple hosts and have them still communicate with one another as though they were on the same host. So the DHCP and router guard, I mentioned that, prevents the host from broadcasting DHCP packets, or protects the rest of the network from receiving them. And the router guard protects the virtual machine from virtual machines acting as routers and advertising and saying, I'm a router, and having this virtual machine pick it up and go, oh, that's my router now, that's where I should go. More important in the IP version 6 world. NIC teaming, I mentioned that. I could have 4 physical network adapters, for example, teamed together, and then provide that network traffic to my virtual machine. So that gives me obviously improved throughput. If those are high-speed network adapters, I can get an aggregate speed from all 4 of them, for example. The port mirroring capability, so traffic sent to or from the Hyper-V virtual switch port for this particular virtual machine can be copied to another machine. Basically, we define one as the sending and one as the receiving, and then that receiving or network monitor machine, as is shown on my slide, receives all the traffic that is, for example, that is sent from or to workstation. Right? So workstation is the sender of all of the traffic on that port, and network monitor becomes the receiver. So basically, you just plug those two into the same virtual machine, the same virtual switch, and you say these are both going to use monitoring capabilities. One is the sender, one is the receiver. It helps us in debugging sort of deep, low-level network issues. Some other improvements in performance there, the receive-side scaling for the virtual machine queue. So this is network traffic Essentially, we change the size of the receiving window on the fly for high-quality networks. And the dynamic virtual machine queue can leverage the NIC hardware. So if the network adapter card itself is high-end and has the ability to sort and route and do packet filtering, we can use that facility directly to get the traffic into or refuse traffic into the virtual machine. As I mentioned, IPsec task offloading, which is a significant processor overhead for doing the encryption in an IPsec network traffic. The actual physical NIC that is going to do this, or you're going to offload this work to, must support the IPsec offload, task offloading. But if that's the case, then I can take that work away from the processor of the host machine or the virtual machine. Right? And you can limit the number of security associations that can be offloaded, but it's up to 4,000 or something like that. I forget the exact number now, but let me just have a quick look here under my acceleration features. No, that's not NIC teaming. Hardware acceleration. What am I thinking of? There's a lot of settings in here. It's easy to get lost in amongst all the settings there. But these are where the NIC teaming settings are, the router guard setting, the DHCP guard setting, and you can also, this is where you can also specify if you want to use a static map, a static MAC address. Right. Just one second here. I think I need to look at the virtual switch manager for that. So my backbone here, extensions. No, can't find it for the moment. But there is the facility. Oh, I know where it is. I'm sorry. I've gotten virtual machine, storage, simultaneous NUMA. No, I'm actually having a little bit of a brain gap here. I'm not sure where that thing is right now. I was looking at it yesterday, and I can't remember where it is now. I was mentioning the single root I/O virtualization. So if the physical adapter is capable of this, this allows the physical NIC to connect directly to the virtual machine without going through the host's network stack. This gives us quite an improvement in networking performance, and that's also available on the virtual NIC. So I can specify this NIC is going to go to the physical NIC. This virtual NIC is going to go to this physical NIC directly without going through the host operating system. So traffic that comes in basically bypasses the host operating system and goes directly to the virtual network adapter. Sorry, the slide here has a few builds in it. So that was a bypass packet, right? Rather than going through the host implementation of the virtual, Hyper-V switch, it goes directly to the virtual machine. So I mentioned the physical virtual LANs, which is kind of an oxymoron, but it allows me to do multi-tenanting. So I can guarantee isolation between multiple customers in the same Hyper-V infrastructure, and I can also do IP address virtualization. So I can do IP address rewrite as packets move through that infrastructure. So essentially, it's using the generic root encapsulation feature to say I'm going to send a packet from virtual machine A on host A to virtual machine C on host B here. I'm going to send it through a physical network that connects the two hosts together, but as far as the virtual machine is concerned, it's not aware of this. It's basically doing tunneling through our physical network to get it to the other host. We also can do IP address rewriting so that two tenants can share the same IP address without any concern for us, because tenant A the virtual machine for the first tenant is machine A on the left is talking to the machine C on the right. These are two tenants. They actually get rewritten to a different IP address to pass over the physical network, so that we don't get any collision between the traffic at all. So it gives us complete isolation between those. So that essentially gives us virtual subnets. So we can specify a ID for each subnet, for each component of a company, each area of a company, and the traffic is isolated from those other subnets. Sorry. And because there's isolation there, we can then do multi-tenanting, which is probably not something that many of you have to do, but if you're looking at leveraging your own Hyper-V infrastructure to support virtual machines for other companies, you can now essentially put them on the same hardware, but guarantee that they won't see each other, won't see each other's traffic, because that information or that network traffic is isolated into a virtual subnet. If you need to, you can also set up a Hyper-V virtualization gateway that enables essentially the integration between physical computers on your network and virtual machines inside your Hyper-V host. Right? So I can do hybrid implementations of a number of physical machines that can't be migrated to virtual for whatever reason, and a number of virtual machines sitting inside a Hyper-V host. Right? So it gives you a sort of build-out possibility for those kinds of scenarios. I mentioned the Hyper-V extensible switches are a large part of this. So one of the things it gives us there, I'll talk briefly about that. It gives us some traffic tools and tracking. It gives us quality of service, and it can also be used for data center bridging to get, as I said, virtual machines from different hosts talking to one another basically virtually or privately across tunnels. So the Hyper-V extensible switch itself allows extensions to be written. So there are a couple that come with it, the monitoring one and the NDIS one that come with it. But you can write your own. So you can extend the switch to do anything you want to do. You could do auditing of traffic. You could do a custom encryption of traffic if you needed it to between hosts by using your own extension for the switch. Right. So obviously we're not going to get into the details of that in this short presentation, but just be aware of that if Hyper-V networking between hosts doesn't do something that you need it to do, it's now extensible. Or even, actually, it doesn't have to be between hosts. As long as it's traffic flowing through the switch, through the Hyper-V switch, virtual switch itself, I can write an extension that modifies the traffic. Right? And that extension is first class, meaning it has access to all the traffic that flows through that switch. Right? Anyway, so more robust feature set. I've got, as I said, port mirroring, trunk to a specific virtual machine, capture extensions, switch extensions, and I've got tracing on the virtual switch itself. So I've got quite a lot of tools there. And the bandwidth capability allows me to specify minimum and maximum bandwidth for traffic by virtual switch port number. So you connect to the switch, this virtual machine connects to the switch, here's the bandwidth that this virtual machine needs, the minimum or maximum. So I can ensure a minimum level of performance on the network side or prevent traffic from exceeding a certain level, or both. So those are configurations that are available for the virtual switch implementation on the virtual machine. Okay, so excuse me. If in addition, in conjunction with compatible hardware, we can also do data center bridging, which, as I said, allows me to use a data center infrastructure to move traffic between virtual machines on different hosts. Data center bridging allows me to specify priorities and bandwidth percentages for different kinds of traffic. So I could say, I'm going to set up this very fast, let's say 10 gigabit backbone for my data center. I want the traffic on there to be allocated 25% for virtual machine-to-machine communication, 25% for live migrations, 25% for audio-visual, that kind of thing. Right? So I can specify specific bandwidth restrictions or reservations across that data center bridging infrastructure. And that enforces a minimum quality of service between the components that are using that configured network traffic. Basically, it's based on protocols and ports. So you can say, all traffic in this protocol or all traffic destined to this port or what have you has this many percent of the overall bandwidth available. Hyper-V also supports non-uniform memory access. I mentioned this, and scaling. So they've done a lot of work on the scaling capability of Hyper-V. I'll talk about that briefly. Some of the scale-up prerequisites that are met by our Hyper-V implementation in Server 2012. I can now do live migration to other hosts. So why is this a scale-up capability? Well, I may have one host that hosts 10 virtual machines, and I find that that host can't keep up with the workload. Well, I can set up another host, install Hyper-V on it, and then start migrating some of the virtual machines from one host to the other while they're running. And I can scale it back as well. So if I find, that initial workload that we were seeing was only due to a new product rollout or a new implementation, and now that's not as popular or doesn't require as many hosts, I can scale it back. I can move virtual machines back from multiple hosts to a smaller number of hosts. So that helps me to tailor the performance and right size. I don't like that word so much because it has other connotations, but right size the number of hosts and the capabilities of those hosts for running my virtual machines. So Hyper-V gives us that. It also gives us scale up, and this is in 2012, of course, but it gives us scale up to support 320 logical processors per host. So that could be, 160 processors with 2 cores, but more likely to be, 10 processors with 32 cores. But I can do 320 logical processors. I can support 4 terabytes of RAM per host, which gives me lots of room to run virtual machines. I can have a cluster using 2012 of up to 64 nodes running virtual machines, and in that cluster I can have 4,000 virtual machines. So I can move those virtual machines around between the hosts. If I have a very large requirement, or very large infrastructure requirement, I can set up a lot of hosts, all with a lot of RAM, all with a lot of processors, all costing a lot of money, of course, but in any case, it gives me the ability to host a lot of machines and move them around and tailor the workload to meet the demand, or tailor the hosts to meet the workload that is being demanded by the virtual machines. Each Hyper-V virtual machine itself now supports up to 64 processors. And that was a limitation in previous versions of Hyper-V of 4. In my implementation here, I can still only specify 4 because I only have 4 physical processors. But if I go to the settings here, in the processor section, right, you can see I've got a spin box here, but I can only get up to 4. And that's because I only have 4 physical processors. But if you had 64 cores, you could allocate 64 cores to this running machine. On one of our implementations, we have a terminal server machine which is quite busy, and we gave it 16 processors, right? Out of the, I think, 32 processors that were available on that particular host, the virtual machine has access to 16 of them. They're virtual processors, but they are reflected in the physical implementation of the machine. And each virtual machine can have a terabyte of RAM associated with it, which gives it a lot of room to work. And as I mentioned earlier, with the new VHDX disk implementation, I can have each of the many attached disks can be as big as 64 terabytes. Right? So lots of scaling up capability within Hyper-V itself. We also have some ability to move data around using offloaded data transfer. This requires some specific directly attached virtual hard disk implementations, but it gives me very good support for moving data around, and it works with the SCSI implementation, so not supported for the virtual IDE controllers. You have to use virtual SCSI devices. But once you do that, and that SCSI adapter is connected to the hard drive, you can get very fast data transfer rates because you can offload the data transfer to the hardware. If like a lot of the things I've been talking about so far, and you probably figured this out, but offloaded data transfer requires offload data transfer capable hardware. Right? But if you have that, I can offload the transfer. You say, well, the virtual machine needs to do that, but let's let the hardware do it, right? Rather than letting the processor work away at that. I was talking about NUMA. So NUMA allows me to control the amount of NUMA nodes or NUMA processors and the amount of memory that's associated with that, and the maximum NUMA nodes that are allowed on a socket in a multi-socket environment. What that allows you to do is spread the processing around across multiple processors in different sockets and let them use the memory that's close to them. NUMA is a more complicated topic, I guess, but essentially in a host, I can have multiple NUMA nodes each of which has a number of processors and local memory. The idea behind NUMA is that the processor is faster at using the memory that is close to it, that is within its own NUMA node, rather than using memory in another node. So an optimal implementation lets us do that. The virtual machines then can use these NUMA nodes. So when I specify a virtual machine, I can say you can have 4 NUMA nodes and this much memory associated with it, and the attempt will then be to map the virtual machine to the NUMA implementation in the host machine to get the most efficient memory and processor workload out of the host machine. A little bit of scale comparison, just to give you an idea where we've come, how far we've come with 2012. In Windows Server 2008 R2, we can have 64 processors on the hardware, and we can have 320 now. We've stepped the memory up from 1 terabyte to 4 terabyte. We've gone to 64 cluster nodes. We only used to be able to do 16. Maximum virtual machines per cluster has now been upped from 1,000 to 4,000. So if you've got a very large infrastructure requirement, you can have a 64 node cluster with 4,000 virtual machines distributed across that 64 node cluster and moved around as needed. Virtual processors per virtual machine, as I was saying, that was previously limited to 4. Now it can have up to 64. Used to be limited to 64 gigs of memory. Now we have 1 terabyte. That's a significant improvement there. And we can do live migration in 2008 R2, but we did have some infrastructure requirements. Now in 2012, we can do it basically without limits. We can do as many live migrations as we configure the machine to be able to do. And live storage migration now, I can move the storage from one location to another, again with no limits. Of course, assuming that we have the hardware infrastructure to support that. And active virtual machines, we had 384 on a host in 2008 R2, and now we can have 1,024. And we can now use, as I said before, SMB or file server storage for our virtual machines, which was not possible in Server 2008 R2. It had to be either direct attached or pass-through or SAN. iSCSI or Fiber Channel, didn't matter, but it had to be SAN infrastructure in 2008 R2, which meant that a lot of people couldn't use storage for their virtual machines that was separate from their hosting infrastructure because they didn't have a SAN. But now they can. They can just set up a powerful file server without having to invest in the money to set up a SAN and store the virtual machine hard drives there. Okay. So a couple of things I want to talk about to finish this up. I want to talk about some of the nice features of Hyper-V Replica and live migration. So Hyper-V Replica is a feature that they provided in 2012. We didn't have it in 2008. That allows me to keep a warm copy. I guess warm's not quite right because it's not running, but a reasonably up-to-date copy of a virtual machine on another node. And it doesn't have to be a cluster. None of the features I'm going to show you require clustering. And I can keep that other one up to date by basically shipping the changes from the first virtual machine over to the other host. And then I can plan a failover. I can test the failover, or I can have an actual failover where the source machine is lost. Okay, so that would be an unplanned failover. Essentially, it provides asynchronous replication. Right? So as changes happen in one location, they are asynchronously replicated to another location. This could be your disaster recovery site. Right? Failover with minimal downtime in a disaster. I can just choose to start the other machine, and it will start up with the same name, the same IP address, and everything, because it's basically a replica. Configurations can be dissimilar. I can have the storage put in different places on the replica. It doesn't matter. Domain membership's not required, and I can restore to a point in time if I create snapshots as I go along. And you can get at this through software if you need to do customized disaster recovery. And it enables infrastructure as a service for hosting providers as well. Minimal requirement, no special hardware, must be running Server 2012, must be running Hyper-V on Server 2012, obviously. And, you can be co-located or physically separated. All we need is a reasonably fast network, although it is designed to run over high latency networks. All that means is that the replica might be a little bit more behind, right? But it'll run over fast networks as well. And the idea here is to give us disaster recovery, not to move machines around. We have live migration for doing that. I'm going to talk about that shortly too. But essentially, Hyper-V gives us unplanned and planned hardware failover, if you will, rather than live migration, which is designed primarily for planned, well, it is designed for planned events, because I can't get a live migration without doing it myself. So I have to know I'm going to do it. And it's a synchronous data copy, so the other machine is exactly the same as the first one. The Hyper-V is an asynchronous thing, so it may not be up to date. So to configure replication, we have to set up the host to support replication. We have to say how the replication will happen for the Hyper-V replica. So there's some details there. Once I do that, my Hyper-V replica can be set up by either doing it directly over the network, I can send a backup copy to the remote site, or I can use an existing backup copy of the replica server. If you're going to set it up and it's very large, you might want to use one of those other mechanisms rather than doing it live, because it will take some time to set up the replica across the network. But it can be done. So essentially what happens then, once I have a replica or a virtual machine set up, all the changes that happen in the host machine are basically captured into a HRL file. The HRL file is sent across to the replica site and applied to the replica virtual machine. Right? So this is a 5 to 15 minute cycle, as they mentioned on the slide there. Right? And the virtual hard drive at the replica site will be at the most that much out of date. You can check. You can look at the replica status and see how up to date it is. Okay? If you want to do this in clustered environment, then you have to set up a Hyper-V replica broker. That's another issue. And there are, of course, some security considerations around that. So planned failover in that environment says, okay, I need to move this virtual machine to this other host because the original host is dead or dying, or I need to do some maintenance on it. Well, I just simply tell it to fail over. Then this new, what was the replica becomes the primary, what was the primary becomes the replica, and assuming that I bring back up the original primary, replication will continue again. There will be some downtime required because basically I'm going to shut down the first machine in order to start it up on the second machine. And that's a planned failover. You can do a test failover where you can say, okay, this is a replica, let's see if it would work. And it will start up a test VM based on the replica, but not connected to the network, so that you can then use remote console and check that the virtual machine is running correctly, so you can make sure that it's a viable replica. Okay, an unplanned failover, if the first machine fails, you can say on the second machine, you go live. So you're going to become the live machine here. And in addition to this, they've improved Windows Server backup, so it backs up virtual machines, individual virtual machines, and backs up the host infrastructure. Okay, so let me quickly show you that if I have a second here. I'm going to set up file server. I'm going to tell it I want to enable replication. I want to replicate it to server 3. Okay. This is my authentication configuration. This is where I'm going to put it on the other machine. Next, and this is where I can specify whether I want recovery points. So if I'd like it to remember the last 4 replications it did, so I can go back to one of them. In the case that I've had a catastrophic change to data, for example, I can select that. Otherwise, I can just say only the latest recovery point. And do I want to start the replication immediately, or do it here at this time, and how do I get it across? Remember, I was saying using a backup that exists on the destination, or some other backup that I've created, or just send it across the network. This is a small machine, so I can send this across the network. So what this will do, you'll see it's starting to do replication here. It's sending an initial replica. I'm sorry, that's kind of small. You may not be able to read it. But it says sending initial replica. Right? On server 3, I can see that file server has been created already, and it's receiving those changes. Right? As soon as that replication is completed, I'll show you the failover capabilities. So I'll let that run in the background. The other feature that I wanted to talk about, and this is going to finish up my presentation here, is live migration. Live migration and storage migration, and live migration using server message block or file shares, in other words. Hyper-V in Windows Server 2012 introduces a number of improvements here. I can do faster migrations. I can do simultaneous migrations, because in the previous version I can only do one migration at a time. I can have my machine with its hard drives on a file server. I do migration that way, and I can do non-clustered migration, so I don't need a cluster anymore to migrate virtual machines in real time. The idea behind a live migration is that the virtual machine that's running on one machine is moved over and running on the other machine after the migration is completed, but the user is not aware. They're just connecting to the name. So if it was a SQL server or a web server or whatever, they're still just connecting to the name. Everything about the machine has been moved over and running on the other machine. What happens is we basically do a copy of the VHDs, and then we copy what's changed on the VHDs, and then we move the memory over, and then we switch the network connections. Okay, but it's done in live time. You can also migrate from a non-clustered host to a cluster, or from a cluster to a non-clustered host. So it gives you a lot of flexibility in moving your machines around. So as I said, you can move between two clusters as well if you need to. Using SMB for migration, I can put my content on an SMB share. The host is hosting the virtual machine. It's hosting the running virtual machine. That is the processing, the memory, but the actual storage is sitting out on my SMB share. If I decide to move it, we need to copy over the memory, and that's all. Right? The memory and the state of the machine, but all of the external storage is still on the SMB share. So basically just switch over the file handle to the other host. You can also do this with SAM using cluster shared volume in clustered environments. It gives you basically the same thing. Fast switch over, no need to move the disk space, just need to move the running process for the virtual machine to a new host. There was an older mechanism called quick migration. Basically, it's put the machine into a saved state and then copied it to the other machine and then brought it back up again. And it again required a shared store. None of these mechanisms, live migration itself no longer requires a shared store. So I can do that directly through SMB location, or I can do it with locally hosted virtual machines. They're sitting on the hard drive right in the host. And I can copy those to the destination or target host and then bring up the virtual machine in the other location. So this is basically what's happening. Disk reads and writes goes to the source virtual hard drive. They continue on the source machine. All the disk contents are copied to the new hard disk. After that initial copy is completed, any changes are copied. After the disks are synchronized, the virtual machine begins using the destination virtual hard disk. So if you want to move a virtual machine to another physical location, you can. That's storage migration. Okay? And storage migration is also accessible through PowerShell, as is most of the stuff. So you'll need to configure this at the server to say this is possible. This machine will do storage migrations. It will do live migrations. These are all in the properties of the server. So sitting here, I look at the properties, Hyper-V settings here. Do I support simultaneous storage migration? Do I support simultaneous live migration? What's the maximum number? And what network do I want to do it over for live migration? Which is important because you can dedicate a network just for doing migrations of machines in a large infrastructure. The SMB infrastructure, basically it's the same process except that we don't need to move the disks. We don't need to copy them from the host machine to the destination machine because they're sitting in an external storage environment. So virtual machines using that SMB, they're connected there, right? That's where the disks are. We need to move the virtual machine, we move it to the target host and reconnect it to the disk. And we're basically done at that point. So before I just clue that up with my last slide here, I want to show you briefly. I now have file server running on server 1 and replicated to server 3 here. Right, so just quickly look at the replication health. This tells me it's okay. The one I looked at, which is the server 1, is the primary. Right? Replication statistics are here as well. Okay? And I know that replication health is good. On the other one, on the one I'm replicating it to, I can likewise look at the replication health, see that this is a replica. I can't highlight these things, but that's a replica virtual machine. And it's also, I can see that its health is good. From here, I can test the failover. That will create a brand new virtual machine, disconnected from the network, but running the copy of the file server that we have right here. I can remove replication, of course, if I'm finished with it. I can pause the replication if the network traffic is causing me too much grief, and I can cause a failover where the first one failed. However, in a planned failover, I need to move it from host 1 or server 1 to server 3 right now. I can do replication and planned failover and start the replication machine after the failover. So I'll do a failover on, oops, sorry. Check the virtual machine is turned, oh, right, sorry. Yeah, and the one thing you have to do, that's the important lesson here, is if you're going to do a failover, you have to shut the machine down, right? So I'll just shut it down. It won't take long to shut down, and then I'll fail it over. Now, all that means is that the machine is not changing. There's no replication traffic to be sent over, right? And the other machine has a copy of it that'll be up to date when we're finished. So let me quickly do my replica health. Right, everything's up to date. Less than 5 minutes ago for the last replication, so I'll do a planned failover. Fail it over. Oh, what's wrong there? Oh, not unable to accept replication data. That is not true. That is just not true. Oh well. Let's just check. See here. Replication is replication configuration. Oh, that's interesting. I wonder why that got misset. Sorry about that. Certification based. Use Kerberos. Allow any authenticated server. And okay, so that's like a minor detail. Okay, let's try it now. So replication, plan failover 2. There we go. So now what's going on is basically we're just saying, okay, you're now the replica. All right, so it's failed over, it's completed successfully. I go over to server 3, I look at it, it's running. Right, it's starting up. Well, I shut it down before, right? But if I connect to it, I can see that it's starting up now. Exit, that's fine. This is just a Windows Server 2012 startup screen. They're a little daunting at times because they just go completely black, and you go, what's going on? Anyway, so here we are logged in, and it's now running on that other node. I can also probably show you an SMB migration. So here's an SMB machine. I look at the configuration of this one. I see that the actual hard drive is stored out on a share somewhere. I will move this. So I'll do a move. This will show you the dialog. So before you begin, etc. I want to move the virtual machine. This is the move the storage. If I need to move just the storage somewhere else. Let's try that again. Move. All right. Next, move the virtual machine. And I'm going to move it to server 2. Oh dear, oh dear, oh dear. Sorry about that. Just a slight difference in security issues there. I'm trying to do this on server 1. You can't do that. You have to do it on the host that's hosting the machine. So let's do it on server 3 here, and let me just do it here. So I'll do a move. Choose the move type. Let's move the virtual machine to server 2. That's better. Move the virtual machine to a single location, or you can specify where you want to move it to. I'm going to have it automatically move it to the same location on the destination machine. I'll do it. Okay. So this is moving this while the machine is running. You see it's still running here. But it'll be a lot faster than if I had to copy it. Now it's gone. It's now sitting over here on server 2 and running. Right, so that's just a little demo there on a live migration using SMB. They're a lot faster. You can migrate without it, of course, if I wanted to move this virtual machine, for example. This is not hosted on an SMB, so move the virtual machine to server 3, let's say. Move the virtual machine. Choose where the data is going automatically and finish. That one didn't work. Okay. Oh, right, I did the same process again. I keep forgetting to try to. I'm launching in. It's the one thing that I haven't quite got my into my head yet, is that you have to start the migration from the machine that's hosting the virtual machine to start with. So I'm going to move DC3 here. I'm going to move it to server 2. Move it to a automatic location. Let it choose and finish. Let's see. There we go. So this move will take a little while, but you'll notice that all the time that it's moving, it's running. So anyway, I just wanted to show you those things before I finish off with my last 2 slides here. I know I'm a minute over here, but here's some just a quick review. Here's the Windows Server 2012 new and exciting virtualization features. Are there any of those that you can use? So you should have a review of that product when you get a chance. And if you're interested, we are offering, of course, through CTC Train Canada, training in Windows Server 2012. Here's a list of the courses. The one that covers Hyper-V in Server 2012 directly is this last one on the list, 55021A. but all of these courses cover the Windows Server 2012 platform, and many of them touch on Hyper-V. It's just that the last one concentrates on Hyper-V.